All right. Um, Hello, class. Good afternoon. Um, I see there are about 4 of you viewing right now, 3 or 4 of you. So, hello. Thank you for joining in real time. Bug says hi. This lesson's brought to you by Bug. And I'm going to set him down in his dog bed, which is right here. Lay down, Bug. So, yesterday we talked about resistivity. So that was just kind of a topic that was all by itself. So we're going to talk about some more circuits today. All right. Hi Nihar. Thanks for joining. Hi Sofa. All right. So yeah, if you're watching, say hi. Hey Akshay. Hey Christian. Thanks for joining. So yesterday we talked about resistivity. That's a topic on its own. So we're moving on to some more circuit stuff. But I have to tell you about some fundamental circuit rules, okay? So first, a really fundamental circuit rule is that things that are in parallel hey Charlie's watching. Things that are in parallel always get the same voltage. Okay? So if you have two things that are in parallel, you can be assured that they will definitely have the same voltage. So for example, if you had hi Galen. So if you have two things that are in parallel, let's say I have a circuit like this. Okay. This is resistor 1, this is resistor 2, this is resistor 3. Well, resistors 2 and 3 are in parallel. So you can be certain that they are getting the same voltage. It might not be the same as the voltage of the battery. Okay? But you can be certain that they are going to get the same voltage, whatever that voltage is. Is 1 going to get the same voltage as 2? No, because 1 and 2 are not in series. The reason that they're not in series is because you have this, it's not 1 directly connected to 2, it's 1, and then the wire branches, and then it goes to 2. So that's not a parallel connection, all right? So they're not going to have the same voltage. Only things that are in parallel have the same voltage, for sure. Okay? The second key fact is that things that are in series always get the same current. Okay? All right, so if two things are in series, maybe I'll add a fourth resistor here. See how resistor 3 and 4 are in series with each other? And so because 3 and 4 are in series, they would get the same current no matter what. Okay? That current is going to be different from the current that flows out of the battery because the battery's current is going to come out and it's going to hit this junction and it's going to split. So resistors 3 and 4 will get actually less current than the battery is outputting because that current is being split. Some of it's going through resistor 2 and some of it's going through resistors 3 and 4. Well, amount of current that these two are getting will be different from the amount of current that these two will be getting. So I hope that, okay. So I have a mnemonic to help you remember that. And it's a really bad mnemonic, and the fact that it's so bad makes it easy to remember, in my opinion. So the mnemonic is SIPOV. SIPOV. So series things get the same current. Parallel things get the same voltage. So remember that mnemonic. It's extremely useful. Okay? So let's use these to solve two different types of circuits. The first circuit is called a what's called a voltage divider. All right. Okay. So here's what a voltage divider looks like. You've got a battery, and then you have two resistors. You could have more, but the example I'm going to do has two resistors. Okay. Maybe this is a 1 ohm resistor and this is a 3 ohm resistor. Okay. And let's say that this is a 100 volt battery. So what we want to do is we want to figure out how much voltage does each resistor get. Is the 1 ohm resistor going to get the same voltage as the 3 ohm resistor? The answer is no. Okay. Will they get the same current? Yes. The reason that they will get the same current is because the 1 and the 3 are in series. But they're not in parallel, so they're not necessarily going to get the same voltage. Okay? So let's figure out what is the current that flows out of the battery. The current that flows out of the battery is the potential difference divided by the resistance. How much potential difference do we have in this circuit? 100 volts. Okay, 4 ohms of resistance. So that means that the current is 25 amps. That's the current that flows out of the battery. So we have 25 amps flowing this way. Okay, but the battery is in series with the 1 ohm resistor. So that means that this 1 ohm resistor is going to get 25 amps. Okay? And the 1 ohm resistor is in series with the 3 ohm resistor. So that means that the 3 ohm resistor is also going to get 25 amps because they're all in series with each other. Okay? Oh, I see Aiden has logged in, so thank you. Hello, Aiden. All right. So everything got 25 amps. Okay. Now, what if I wanted to know how much voltage does the 1 ohm resistor get? Well, according to Ohm's law, the 1 ohm resistor is going to get I times R of voltage. That's what Ohm's law says. V equals IR. So what we want to do is we want to figure out, well, how much current does this resistor get? And we can see that right here it gets 25 amps of current. And how much resistance is that? It's a 1 ohm resistor. Okay. So its resistance is 1. So that means the voltage that the first one is going to get is right here. So now we want to talk about the 3 ohm resistor. And its voltage is also I times R. Its current, we said was 25 amps. So I is 25. And R is 3 ohms. So we get 25 times 3. All right. So that is 75 volts. So if you look at it, see how when I add these two up, what do I get? I get 100 volts, okay, which is the same as the voltage of the battery. So that's the reason why this circuit is called a voltage divider, because you're taking the voltage of the battery and you're sharing it between two resistors, okay? What if these two resistors were, representing light bulbs? Then the one that gets the bigger voltage is going to have the larger, is going to be brighter, essentially. Okay? So if these were two lights in your house, then you would expect that one to be the brighter. To the live chat. So if you, okay. And then the second example I wanted to talk about today is something called a current divider. All right. And a current divider circuit consists of source and a 3 ohm resistor, and this is a 2 ohm resistor. I got a question. Will you be going over the questions in the daily item? The daily item, if you want to talk about the daily item, we're going to talk about that in the discussion after all the lessons. So we should be done with this lesson by 2:30, and so I'm just going to jump over to Discord, and you can ask me whatever questions you have about the lesson. Or the daily items, okay? So, what does this symbol mean? This is the symbol for what's called a current source. And a current source is kind of like a battery. $40 amps comes out. It hits that junction. Some of the current is going to go here through the left branch of the circuit. Some of that current is going to go this way through the right branch of the circuit. Okay? Now, current is basically conserved. All right? I'm going to talk more about that later on this week, but current is basically conserved. So, if we were to take the sum of the two currents in the left branch and the right branch, that's going to equal 40, because 40 came in, so 40 is going to go out. Okay? So that's one equation. Another equation is, notice that the 3 ohm and the 2 ohm are in parallel. Okay? And according to what I said the other day, or earlier today, just a couple minutes ago, things that are in parallel always get the same voltage. So these two are going to have the same voltage. So the 2 ohm resistor, okay, is going to have the same voltage as the 3 ohm resistor. Now, how can we get the voltage across a resistor? We would use Ohm's law. So the voltage across the 3 ohm resistor is going to be I times R. Okay. But if we think about what is the 3 ohm resistor, well, the 3 ohm resistor has a resistance of 3, and the current that goes through the 3 ohm resistor is the left current. So the voltage drop across the 3 ohm resistor is the left current times 3. For the 2 ohm resistor, its voltage drop is also I times R. But the current that the 2 ohm resistor gets is the right current. So I sub R, and its resistance is 2 ohms. So I sub R times 2. So basically the fact that these two resistors are in parallel means that this equation is true. All right? So that means if I divide both sides by 2, I get that the right current is equal to 3/2 times the left current, or 1.5 I left. All right? So now I can take that. The right current is boop. All right? Which means 2.5 I left equals 40. Which means that I believe that means I left equals 16 amps. Let me double check. 40 over 2.5. Yeah. Okay. Now, if I left equals 16 amps, then that means that I right is the remainder of the 40 amp current. So it's going to be 40 minus 16, which would be 24 amps. So from an intuitive standpoint, the one that gets more current is the one that has less resistance. 2 ohms is less resistance than 3 ohms. So more current goes this way than it goes this way. All right? Current prefers to take the path of least resistance. Does all current take the path of least resistance? No. It spreads itself out between all possibilities, but most of the current is going to go through the path of least resistance. Okay? So why is this called a current divider? It's because it takes the 40 amps and it divides it between the two branches. Okay? So tomorrow I will be discussing some applications of these circuits, and it should be fun. So thank you for joining me, and I will talk to you tomorrow. I'm going to jump over to the Discord server right now, and I'll answer any questions you have. Okay, bye.